In this lesson, we'll be defining a Waterjet cutting toolpath. After completing this lesson, you'll be able to create a 2D cutting toolpath. Let's carry on with the file from our previous example. In our case, after we create this setup, there's not a whole lot of work that we need to do other than setting up our toolpath. Under the cutting section, we want to locate the tool that we want to use. That's important anytime you're creating a CNC program to understand the parameters of your specific machine. In our case, we're going to select, and notice that the FPV Racing Chassis documents does not contain any type of tools yet. If we go to our local settings, or documents, or samples, we can see a few of the different machines that we have access to. If you've done any work inside of Fusion Cam, you may or may not already have a local library. If you don't, you can also deselect that so that you're not seeing any tools. I'm going to be using the sample library, and notice that we have several different types of cutting tools here. What we want to do is we want to focus on the operation type. So we're going to filter by cutting and say OK, and this will only show us the available cutting tools for 2D, things like a CNC controlled plasma cutter, laser, or water jet. Now in our case, we're going to be using a 0.5 millimeter water jet tip. If you need a specific tip, you have the ability to create a new tool inside of your local library. If we turn the local library back on and we select it, we can expand this and we can create a new tool inside of our local library. You'll notice that we can set the cutter type to be water jet. We can set the kerf width. If we want to do a very small tip, 0.25, nozzle clearance diameter. We can set any specific parameters about the holder, any feeds and speeds that are specific to your machine, and specific post-processor values. Now in most cases, if you're dealing with a CNC machine that has a tool changer, these NC numbers will be very important. If you're dealing with a water, laser, or plasma cutting machine that only holds a single tip, it's not nearly as important. For our purposes, I'm going to go back to the samples, and again, I'm only going to use the sample provided tools, in this case the metric 0.5 millimeter water jet. We're going to say OK, and now we have the tool shown inside of our 2D profile. If you rotate the view, you'll also notice a preview of the tool located at our XYZ coordinate system with our Z above the part. We're going to rotate the view just slightly and take a look in the feed section. I'll be leaving all of these values as default, but again, these are specific to your machine. In the geometry section, we need to define which areas we want to cut. So the first thing that I want to do is note that we have loops, all loops, outer or inner loops, and we also have to start outside, inside, or specifying that it's always outside or inside. Now in our case, I want to do the outside profile last. I want to cut all the internal geometry first, and then we'll do the outside profile in its own operation. So let's go ahead and specify that we're going to do all internal loops. Now notice we automatically get a loop selection depending on where your cursor is. So I'm going to start from the upper left-hand corner, and I'm going to focus on cutting each of these slots. Now each time we cut a slot, we'll have a start and an end where we'll overlap, and then it'll exit that section. We'll go into here, and notice that we're selecting these loops even though we don't have tangency around these corners. Then we're going to work our way around. I'll go to each of these slots, and notice the arrows are pointing the interior direction. So it's telling us which side is the inside and which side is the outside. We might need to come back and adjust these chains depending on how the preview looks. We're then going to work our way down. I'm going to work my way through these profiles. And then we'll jump back over here. Now the important thing is we want to try to minimize the amount of time the tool has to raise and move when it's not cutting anything. So in this case, we're going to have to jump back over, but that's going to be okay in our case. We're not really wasting too much time, we're minimizing the amount of non-cutting moves as much as possible. Now, in some cases, the geometry works out better for that, and in other cases, you will have a lot of time where the tool is just in the air moving from place to place. Now that we have all the loops, if we take a look at it, you'll notice that in each section, when you highlight one of these loops, we can flip the arrow to cut the inside or the outside. Now, it's a bit harder to tell when you have smaller holes because the cursor is not inside, but you can see with these loops that we can move the arrow inside or outside depending on which section we want to cut. And again, it really is hard to tell on some cases, and you notice that we missed this one here. In some cases, it's really hard to tell whether it's inside or outside. You might have to come back and adjust these later. So we're going to say start inside for all of these. We're going to move over to the heights. If we rotate this around, we get a preview of each plane. We have a retract height, which is where the tool will start and stop. We have a stock top, and we're retracting above that 5 millimeters before we turn the jet on. And then we have the top height, which is set to 0 millimeters, which is where our WCS is located. Now remember, we didn't have any additional stock on the top. If you accidentally left a millimeter on top, that is where that value would sit. In the passes section, here's where we have control over what the tool is actually doing. Our tolerance is set fairly tight, 0.01 millimeters. Remember, we set these holes to be exactly 3 millimeters, so that way if we need to drill them out, we can. If they come out a little bit larger, that's okay. We have sideways compensation. Now in our case, we can have left, right, or center. Now remember that the tip on this specific case is 0.5 millimeters wide, so there is a small amount of compensation that does tend to happen. For compensation type, we can do in computer or in control. Again, it's specific to your machine how you really detail that wear. We can also preserve the order if we want to. There's a smoothing option in here with some smoothing tolerances that can help filter some of these arc corners. In most of our instances, we have straight lines, so I'm not too worried about turning smoothing on. If you had a really spline or arc intensive design, then you might want to consider some of the smoothing options. And lastly, we have the linking section. We have keep nozzle down, which will keep it from retracting up to that clearance plane every time it moves. I'm going to keep it down as close as possible, and it keeps it down as long as it's moving less than 50 millimeters. Since we have an overall distance across of 250 millimeters, we really don't have any areas where we're jumping more than 50. So this will be okay for us. We have force retract for inside cut. That's an option that we can turn on. We also have a stay down feed rate, so we can adjust that as opposed to the normal cutting and rapid feed rates. We have some information about how to lead in and lead out of some of these holes. We have a sweep angle, so it's going to go 60 degrees across the cut. We have a lead-in distance of 5 millimeters. This will not work in the smaller holes because we have 3 millimeter holes. So I'm going to use a smaller lead-in distance of 1 millimeter, and I'm going to use it on the exit as well, using the same value. We also have piercing clearance, and we can specify an entry position. Because we have so many holes in this design, it doesn't make sense to have a specific entry position. If you're only cutting one hole, then that would be a different story. We're going to say OK, and it's calculating, you'll notice in the browser, and then it shows the toolpath on the screen. All the yellow lines are the rapid movements. If we zoom in, you can see it's coming down. You can see the lead in, it'll cut the path, and then it'll lead out past that. And then it'll go to the next cut. So let's go ahead and zoom to fit, save our file so we can move on to the next step.